So today I'll be talking about a project that I've been working on that involves using Plotly Dash to create an interactive web application for a firefighter. And then towards the end of the talk, I'll share some key takeaways I've had from the project so far that can be applied to making these kinds of applications specifically for non-technical or unfamiliar end users and audiences. So a little bit about myself. I'm a research engineer at Underwriters Laboratories. And for those of you who aren't familiar with UL, we're a safety certification company. So we do a bunch of consumer products testing, everything from smoke alarms to computer chargers to the exit doors in this building. If you look close enough, chances are you're going to find that UL logo indicating that it's been tested by us. And so our company's a pretty big company. We have over 14,000 employees in nearly 50 countries around the world. And working for UL has just been excellent. They're a very strong and mission-oriented company, focused on the mission of working towards a safer world. And the higher-ups have been very supportive of specifically of the group, or the work that the group I work for does. So UL is a for-profit organization, but there's also a non-for-profit side. And the group I'm a part of is actually on the non-for-profit side. And we're the Firefighter Safety Research Institute. And we're based out of Columbia, Maryland. And our main focus is to conduct research that's focused on advancing the knowledge of fire behavior throughout the fire service, and then as we continue to grow and expand throughout fields that are adjacent to the fire service. So essentially, my job is, along with other engineers in our group, is to light things on fire. And of course, study and measure them and analyze results, and then present it to our stakeholders. But another way I like to put it is that we're a bunch of pyromaniacs who have found a way to channel our urges towards the greater good. Just to give you a quick idea of what it's like, specifically when we're out in the field testing, I'm going to share this quick 30-second video. It was made by our extremely talented content developer, Josh, and it contains footage from experiments we did last July in Cobb County, Georgia. So in terms of programming background, I have what I would consider a casual programming background. And by that I mean that I took a number of engineering courses in undergrad that required me to learn C, C++, and LabVIEW, and other languages. But by far the language that I use the most and that our group uses the most is Python. I would say I'm around the intermediate level of a Python user. So basically I know enough to know that there's still a whole bunch of stuff to learn, especially on the optimization and best practices side. The libraries that I use most often are up here: NumPy, Pandas, Matplotlib. Mainly we use Python for data analysis and generating plots for reports and presentations. Plots that resemble this one, so nothing too complicated. But every now and then a new opportunity comes along at work that allows me to learn new Python skills. And for example, I'm just finishing up a project that uses TensorFlow and OpenCV to extract flame height data from experimental video. And then we can use that flame height data to verify and assess models and predictive algorithms that are used by fire investigators when they're trying to recreate a fire scene. So this desire to kind of learn new Python skills is part of the reason that I became involved with the project I'll be talking about today. So today I'll start with a little bit of background and motivation about the project. I'll provide everyone with an overview of Dash for those of you who aren't familiar with it. Then I'll talk about the dashboard and how it got to its current state. And I'll provide a quick demo of the dashboard. And then I'll finish with some key takeaways that are kind of generalized for creating these kinds of applications. So as you might imagine, I became involved with this project through my job at UL. one day, one of my coworkers pulled me into his office and he started telling me about this firefighter on a rescue squad in Washington, D.C. And just a quick aside for those of you who aren't familiar with firefighter lingo, rescue squad is a group of firefighters who are not only proficient in firefighting operations, but also technical rescue operations. So they respond to fires, but they also respond to incidents where they need to implement these rescue skills. So for example, if somebody crashes their car and becomes entrapped or falls down an elevator shaft and needs to be rescued, chances are a rescue squad will be the firefighters responding to the incident. So anyway, my coworker Keith was telling me about this firefighter named Kelly, and he has this tool called the Arizona Vortex, or AZV for short. And it's a tool that's designed to keep rescue squad workers ropes off the ground while they're performing rescues to protect them. And so essentially you just attach pulleys to the top of the tripod thing there and run ropes through as you perform your rescue. And it's pretty important to know the distribution of forces as you're using it on each leg, because if it's used incorrectly, it could topple over, potentially sabotaging the entire rescue operation. And one of the things that makes this device unique is that the legs can be removed and set up in different configurations. So on the left is one with all three legs, the middle's one with two, and then there's even one with just one pole. So that has been used before. So as this tool's gained popularity over the years, people have been wondering a number of things. What are the different forces on the legs, and how do they differ across the different variations, and how close do they come to the rated limits of the device? And so Kelly was curious about these questions, and then also wanted to test claims that people were making that they had come to through trial and error, and he wanted to put some concrete data behind it. So having no real background in electronics or data acquisition, he started doing research and bought some load cells and a DAC and hooked it up, and he got data. And like it so often does, the first round of data just led to more questions. And he was kind of stuck, so he reached out to Keith, my coworker, knowing his line of work. And Keith thought that might be something that I'd be interested in doing. And so when I heard about this project, I was interested and thought it'd be a perfect opportunity to start learn how to use Dash, because previously I'd heard of Dash and heard great things about it, but had never found a project to use it on. So just by a quick show of hands, who here has heard of Plotly Dash? Okay, so a fair number of you. That's good. So it's a library from Plotly for creating analytical web applications. It's written on top of Flask, Plotly, JS, and React.js. And a big part of the reason it's such a powerful library is that you can create these web-based apps solely through Python. So no JavaScript, no writing your own servers, none of that. And so just to give a quick example, I'm going to pull up an example from the Dash app gallery. So on the Plotly Dash website, there's a page called the Dash app gallery, and it has a whole bunch of different examples of applications that people have made using Dash. It's up to 47 currently, but that numbers keeps going up. The one I have pulled up is about New York oil and gas production. And so you can see here, there's slider components, there's drop downs where you can filter all this, and essentially the components will respond to the user inputs in real time. You can have maps, you have hovering capabilities. These are all Plotly graphs, so you have the zoom capability, fully interactive. And again, that's normally to do this, you would need to know JavaScript. You'd have to write your own server. You would know CSS to make it look good. You probably need to know React, and I'm probably missing a bunch of other tools because I'm not familiar with any of those. So this is the reason that it's such a valuable tool, especially for engineers like myself who are not familiar with what a full stack developer would be familiar with, and this provides us the capability to still make these kinds of web pages. So then we can visualize our data in familiar or new ways and help identify trends and patterns that wouldn't be seen otherwise. And the code structure for Dash is pretty simple and straightforward. I don't really have time to go over a full file, but essentially there's two parts to the code. There's the first part that defines all your components on the page, and then there's a series of callback functions that you write to tell the code how the components interact with one another. So now I'll discuss the creation of the AZV dashboard. So once I heard about this project, I figured a good place to start before meeting with Kelly would be to actually learn more about Dash, get an idea of what the capabilities of the library are, and come into the meeting with at least a little knowledge of it. And I found that the Dash user guide and other resources provided on the Dash website is a really good place to start. And so Kelly provided me with a few example data files from when he initially collected data. And from those and just reading up on Dash, I was able to create a couple very simple examples. One that simulated the live plotting of data, and then one that had a drop-down menu that would display the static plot of the data file that you selected. So armed with these examples, I met with Kelly, and he introduced me to the project and showed me the progress so far. Then we discussed the purpose and goals and the direction that we wanted to take the project. I demoed the examples for him and kind of described the different capabilities offered by Dash. And we brainstormed possible ideas for what we could add to the dashboard, what would make it useful. And eventually we developed a list of initial objectives to get this thing off the ground. And so this is the list we came up with, kept it pretty simple. Essentially, we want to be able to read the data to a file, output the values in real time, and then generate the data plots after the test so they can be looked at afterwards. And all of this on a straightforward and easy to use product. So the first version, like I said, we kept things pretty simple, focused on functionality. It was a little challenging to keep things simple at times because the more I learned about Dash and the more ideas flowed in, and it was hard to keep focused. But instead of falling down the rabbit hole of trying to implement every idea that came to mind at the time that it came to mind, I just jotted it down to try later, and also to check with Kelly before trying it to see if it's even something that he would be interested in having. Because if it wasn't, what was the point of going down that rabbit hole? And then once I had a working product, I met with Kelly to demo it and receive feedback for him, and we prioritized goals for the next iteration. So this is just a quick screenshot of the first version. It fulfilled all of our objectives. You can see there's 3 tabs. There's a setup tab for user inputs, and then there's a real-time plots tab that has the live data plotting, and then there's a post-test plots tab, which has a drop-down to look at previously collected data. And it's, like I said, it's functional, but there's obviously things that could be improved. This drop-down menu is unnecessarily wide. The graph has pretty thin lines, small fonts. So with the second iteration, which is its current version, tried to improve upon a number of these things. I threw some fancy logos at the top, enlarged the font size. I made the drop-down menu less wide, and I gave the graph a distinct color background to kind of make it pop a little. And we are outputting values to the side of the graph now. On the post-test plots tab, it's the max load value from the data file that's selected. On the real-time plots tab, it's the live value that's being recorded. And I also added the capability to log events.
Is there any code that you could show that's behind all this?
Yeah, I can pull up some towards the end. So yeah, and then also in addition to those visual improvements, I essentially just cleaned up my code, removed old comments, restructured it so it was easier for future development, made a separate CSS file, things like that. And now I'll give a quick demo of the dashboard in its current version. So you can select channels and then enter custom names. And then one thing that I added was if you hit start data collection but your fields aren't entered, this populates and tells you what needs to be entered. So you could enter the data type for the sensor because Kelly expressed interest in maybe collecting different types of data. The sampling rate, how long you want your background to be, which we'll just do like 3 seconds here. And then your output file name. And then once all the fields are populated, you can hit start data collection. It starts collecting the background to zero the sensor. And then this is the live plot. And we can log events here. And so you can see I'm polling, so it's intention, so it's positive. And compression. And you can do that to this other one. If you get with a friend, you can see who's stronger. If you're smart, you'll change the calibration values so you win. Then once you're done, you can end the collection, come over here to the post-test files, and there's your plot. And again, fully interactive. And one of the things that Kelly really liked was the fact that you can download this as a PNG. So when he's giving presentations at different conferences, he'll be able to show this data. So just some quick upcoming improvements that we decided on after we met is he requested that a button to zero the sensors while in the test because he wanted to see the forces while everything's static, and then once ropes are run through and everything's in tension before loads applied to it to re-zero it and see what that force is just with the load compared to the overall force on the legs. And then we're also looking at adding sensor calibration capability. Whether that's a new tab or separate dashboard, it's probably going to be a new tab. An indicator light to see or to indicate that you're recording data and output the time since the latest event and the overall test time. And I'm about to give it to him to start using on his own time, so I'm sure he's going to find a number of bugs that'll have to fix. And then eventually we're going to add wireless data logging, probably through the use of Arduinos. So now I'm just going to review a few quick takeaways from this project that I've found important so far. So one thing I found is developing clear objectives from the start. It's very important. Meeting with your audience or client and figuring out what they want. It's important to know that they don't know what they don't know. So the more information you can provide them, whether that's showing them a quick example you made or showing them the Dash app gallery so they can go through and get ideas of what's possible with this tool. And then start simple, just to hit the ground running, and any ideas you have, take notes. Make sure you don't overpromise, or at least not too much. I say too much because it tends, myself included, but motivates some people if they overpromise. And then also, when you're using something that has so much potential, it's kind of hard not to get caught up in like, oh, we can do this and that. But if you just start simple, and then if you start trying to implement something that's not working out, as long as you're consistent with your communication and receiving feedback from your clients or audiences to inform them and give them updates. It's all right. Like I said, take clear notes throughout, whether that's after the fact from chicken scratch notes of ideas that come to the head. Just make sure you organize them after the fact. Think of areas that you write to kind of hack together that you can go back and improve later. And rank in the order of how you want to implement them after meeting with your end user, and start with the low-hanging fruit and kind of work from there. And then it's important to revisit your objectives throughout the development and make sure you do that with the client so you're all on the same page. And then take time to clean up your code as you reach certain milestones. So for me, that was when each version was nearing completion, I would start going back and reorganizing codes and trying to improve it. And most importantly, treat it as a learning experience. If you're unfamiliar with Dash, like I said, there's a number of great resources out there on the Dash website, and then the user guide. And then there's also tutorials on YouTube, and pythonprogramming.net has a pretty good tutorial. It's kind of like a 5-part series about live plotting data. And I think eventually you get into extracting data from Twitter, but I didn't go that far. So again, thanks to all of you for coming out. And one last thing is, if you want to spice up your Twitter newsfeed with pictures of fire, and you can follow us on Twitter at this handle that no one can see because the podium's in the way. But that's it. Now I can pull up a just an example real quick to. So basically, this calls it instance. So Dash has a bunch of different packages that you can import, and this is the first part of the code that I was talking about, where this is defining the layout and the different components. So this basically just has text at the top that says select a file, and then this is the drop-down definition, and this is where the graph is output. And then this is the callback function. So in more complicated dashboards, you'll have a series of these, but this one just has one. And so the first argument is output, what's going to be updated, and then the second is what triggers that to get updated. So this is once the value of the drop-down changes, this function underneath is run, and then it updates. Whatever you return is going to go to the children of the output graph.
That's a question.
Thank you.